Just a second. Now, the fan motor system. Now what we have, COP of the plant is Cm mCp delta T multiplied the duration of the plant power out in kilowatt hour, and COP of the cycle is mCr T6 minus Tr, means duration of the power output in kilowatt hour. The specific heat of the water is 4.18 Cp kilojoule per kg. State of refrigerant given as 1.26 kilojoule per kg. So difference in the temperature of water inside the cooling chamber, COP is the initial and final. COP is 662.1.2, and tonnage of the machine is given as mCp delta T, thereby 3.8 is 27.2787, and then COP of the cycle is 0.24, 0.241164. Determining the efficiency of the refrigerant strict experiment number 3. Here, initial was 1.8, it was final was 2, duration was 3. Initial high pressure is 9 and kg per centimeter square. Final is 15 kg per cm. Low pressure initially 1 is equal to higher is 0.5. The temperature constant with the cold water inside the tray is 31. That fixed at the compressor discharge line. 31 inside the cold, and finally was 0. Fixed at condenser compressor discharge line. That is 35 initially, finally 68 as a rise. Fixed at compression suction line is 32 into 32. Then fixed before condenser 32 into 32. The fixed after condenser is 31, 37. Means fixed before condenser is outlet of the compressor. It remains more or less at the same position. And fixed after condenser, it is more or less in the same position. It is that temperature is not changing much. And after the capillary tube, it is cooled, and it is become initially was 29 and finally become -5. Inside the chamber 31 initially before the start, finally 0 degrees centigrade. So the feed type natural air cooled condenser, cooling chamber, just one air cooled feed type. Next, so you have to put the values here. Refrigerant is 135. The mass of water kept inside the tray in the cooling chamber is around 0.185 grams in kgs. Mass flowed in refrigerant is 0.33 is given. CF of the plant Cp delta T duration, Cp into delta T into mass into Cp into delta T multiplied duration divided by the power input. Cp of the cycle, same mass in the specific heat of the refrigerant, and temperature fall, temperature drop multiplied by the duration multiplied by the power constant. The specific heat of water becomes 1.18, rate of refrigerant 1.26, 4.18 is 1.26, delta T, reference in temperature of the water in the tray is temperature and final, and the COP of the plant becomes 161, the COP of the tonnage capacity machine becomes 6.34. COP of the cycle is 4.55. On the air conditioning test rig, it is the temperature. Initially, final, it was the power was initially 4.8, final was 6.2, and duration is 3.33 hours. The pressure concern, high pressure is to 20 and 21 degrees, 21 and 21 kg per cm square. Initially, the low was 34.6. The temperature concern, the temperature sensor reading is degree centigrade T1, fixed at condenser discharge line 6172, fixed at before condenser T2, ATAS 27, T3 fixed after condenser 2928, T4 fixed at suction compressor suction 2322, fixed at after capillary tube 58, initial -5 after capillary tube, fixed at evaporator or air duct 2120 degree, and surrounding temperature becomes initially 26, become 24 only, not much. The velocity of the cooled air initially and finally was 5. Initially was 5.58 and outline becomes 3.35, and finally 5.51 is 4.51. The flow rate becomes 5.63 to 4.63. Condenser, fin and type, and evaporator cooling chamber. Refrigerator use 140, COP of the plant minus MPR CR deviation multiplied by power output, MR CR into CR into delta T into duration multiplied by power output, it becomes 5.056 COP of the cycle. Temperature delta T is P1 minus T2, 72 minus 22, 52. Specific heat refrigerant given is 1.26. Thus, mass flow of the refrigerant is 0.0033 is given. Its constant capacity of the plant machine is MCR, MR into CI divided by 3.8 becomes 0. Tonnage capacity of the machine is 0.568. Sensible heat capacity is about from this formula is given as 0.645. Relative difference in temperature of the work in the tray is 8 degree. Bypass factor becomes 0.8125. TD1 temperature of the incoming air to the air conditioner, the surrounding room temperature 14 degrees centigrade. Temperature of the cold air count out of the refrigeration sensor. Temperature of the cooling unit is cooling coil is 8 degrees centigrade. The efficiency of the cooling coil is 1 minus BPF is equal to 0.1875. Let us go through now. Let us share the photos of the machine running machines. This is our vapor compression refrigeration test rig. What we are showing here, first, this is our condenser, which is where we are using a cooling fan to cool the refrigerant passing through this passing through the tubes of the condenser. This is we are showing our hermetically sealed compressor, and this is our expansion device or capillary device. This is a digital meter used for registering the power input, and the high pressure of the system is being registered here, running by the red line, and low pressure of the system is being shown in this pressure gauge given by the group green line. This is the temperature. This is the thermometer where we can show T1 to T6 temperature which is fixed at different points of the thermometer itself. Last, this is our refrigerator. This is our evaporator, which is looks like a tank and which contains which contains the cooling coils as shown here, and it cools the water, pool of water contained here. Hello, this is another vapor compression refrigeration test rig. Here we are having the compressor, hermetical seal compressor in front of us. Next we are having the condenser, which is air cooled here and not cooled by any fan itself. Over it we have our two pressure gauges, which indicates the high pressure and low pressure of the system. High pressure is the red gauge and green is the low pressure itself. And in front of us is the evaporator of the system, which is inside a glass ball casing, and inside we are seeing the these tubes carrying the refrigerants surrounding this refrigerator system. Next we are having the digital watt meter, which is measuring the power input during the process running of this refrigerator test rig, and below it the main switch of the system, and above that the thermometer, which records 6 different thermometers as per its setting T1 to T6, which gives us the thermometer of temperature of different portion itself. And below everything, which is showing our expansion device or throttling device, which works as an expander of the system itself. Okay. Let us describe another refrigeration test rig. Here we are showing first the hermetically sealed compressor itself, which is works as a compressor, and behind it we are having our condenser system, which is air operated, and it is totally reduces the temperature of the refrigerant by exchange of heat through the surrounding atmospheric air. Over that we are having our two pressure gauges, which indicates the high pressure and low pressure of the system. High pressure is the system indicated by red one, and low pressure is indicated by the green one itself. At the right of it we are having our expansion device or throttling device, which uses or due to the expansion of the fluid after the condensation is complete. Beyond that we are having our digital watt meter, which is a recorder of power which is being used during the running of this refrigeration test rigs. Next we are having a thermometer, which is recording and showing us that 6 different thermometer T1 to T6 at 6 different points of our circular operation. By its sides we are having our main switch, which is starts and stops the system. Now in front of all of us we are having our refrigerator or evaporator system, which looks like a normal domestic refrigerator itself. Inside of it is familiar to us in our household refrigeration system, and this is the deep fridge, and inside which we are having the tubes for evaporators, and inside below that there is a rack, and into the front door there is a rack itself. This is in short a domestic refrigerator which is being used time to time everywhere in our domestic purpose itself. Thank you. Let us start the operation of our air conditioning system in our laboratories. What we are showing here, the air condition test rig.
In front of us at the top, we are having our digital watt meter used for measuring the energy used during the test period. At the left, next the thermometer itself, which also again records 6 different thermometer temperatures at 6 different points. Below it, the low pressure and high pressure gauges, which is recording the pressure at the low pressure and high pressure side of the system. High pressure side is the red one and low pressure is the green one itself. Under that, we are having our main switch, which starts and stops the system, and over that we have having another switch which is written as on and off, which is used to run and off the switch of the heating coil itself. In the right of it, we are having our expansion or throttling device, capillary device tube, throttling device or capillary tube, which is used as an expansion of the system itself. Inside the carriage cover, we are having a condenser itself, which is viewable at the front as well as rear side of the test rig itself. Inside the fixture, we are having our compressor and the air cooling fan, which is used to dry the air of the cooling system. This is the outlet of the air conditioner. Inside, the white coils, while cooling coils are visible in front of us, and before that, just in front of all of everything, we are having a red-shaped coil, which is as the heating coil, which is used for heating the cold fan, if necessary. This is the overall function of the refrigerator, and this is the intake point of the air, and below that the temperature set for the refrigerator, for the air conditioner is visible here.
Let us have some YouTube videos about this sharing.
Welcome to virtual practical on test on air conditioning test rig. In this session, you will be able to explain practical relevance, importance, and the procedure of conducting trial on air conditioning test rig. You will also be able to determine theoretical and actual coefficient of performance and tonnage capacity of air conditioning test rig. Objectives of this experiment are study of air conditioning system, explanations on performance of experiment, which includes experimental setup, observations, calculations, result tables, and conclusions. Practical relevance of the experiment is: air conditioners are used for domestic air conditioning purpose, automobile car air conditioner, commercial air conditioning used in hotels, shopping mall, in cold storage, in hospital, and central air conditioning system used in multiplex. In all these are applications of air conditioning. So air conditioning means to supply and maintain desirable internal atmospheric conditions for human comfort and product, irrespective of external conditions. There are mainly two categories of air conditioning: comfort air conditioning, which is used in office buildings, commercial sectors like supermarkets, shopping centers, restaurants, etc. Industrial air conditioning, which is used in textile companies, pharmaceutical units, electronics units, manufacturing companies, computer centers, etc. In air conditioning, mainly four properties of moist air are controlled simultaneously. Temperature, which is maintained by using cooling coil or heating coil. Humidity means moisture content of air is maintained by use of dew point temperature of cooling coil. Motion of the air means velocity is controlled by use of fan or blower in air handling unit. Cleanliness means purity of air. Here unwanted dust is prevented by using filters. In a laboratory, in order to conduct the experiment, air conditioning test rig is used. So here are various components of air conditioning test rig: compressor, condenser, capillary tube, cooling coil, heating coil, refrigerant flow meter, dryer, accumulator, suction pressure gauge, discharge pressure gauge, temperature indicator, energy meter, and HPLC cutout. Let us see all these parts in detail one by one. This is hermetically sealed compressor, which is used to compress the vapor refrigerant coming from the evaporator in order to increase its thermal energy level. Thus, its discharge temperature is increasing above the atmospheric temperature. Such hot vapor refrigerant is passing to the condenser, where heat from the refrigerant is rejected to the atmosphere and refrigerant is condensed. So here is a condenser of plate, fin and tube type. So in this, fan is used in order to have force type heat transfer convection. This is evaporator and heater section, where the cooling or heating of the air is carried out as per the requirement of the process. This is capillary tube or expansion device, which reduces temperature and pressure of the liquid refrigerant to a very low level. Duct inlet through which air is passing inside, duct outlet through which air is coming out. So during this, air is passing from inlet to outlet of the duct. In this, either cooling or heating of the air can be carried out by operating the evaporator and heater coil respectively. Accumulator is provided before the compressor. It ensures only vapor which is passing to the compressor. Thus, dry compression is achieved. Suction pressure gauge gives pressure reading of compressor entry. Discharge pressure gauge gives reading of pressure at exit of compressor. Temperature indicator gives reading at the 4 locations in the vapor compression refrigeration system. So 1 is a temperature after compression, 2 is a temperature after condenser, 3 is a temperature after expansion valve, and 4 is temperature after evaporator. Energy meter is used to measure the electrical consumption of compressor. Refrigerant flow meter, inclined manometer is used in order to measure the velocity head of air passing through the duct. HPLC cutout means high pressure, low pressure cutout. It protects the system when the system is running out of pressure at very high pressure or low pressure. In this case, HPLC cutout automatically stop the compressor and make the system safe. Dryer prevents entry of moisture which may pass to the capillary tube. Thus, it may block the capillary tube by the formation of moisture into ice due to very low temperature in capillary tube. Right? This is block diagram of air conditioning test rig. Technical specifications of air conditioning test rig. Refrigerant used here is a R22. Compressor is used here as a hermetically sealed type. These details are already explained. Electrical supply of 230 volts with 50 Hz frequency is used here. AC current is used to run the air conditioning test rig. These are the standard values which are used in further calculations. Here 1 ton of refrigeration effect is taken as 3.517 kJ per second. Area of duct is given. The shape of duct is rectangular. Specific gravity of fluid used in manometer is given. Standard operating procedure. Connect the supply cable to regulated or stabilize power supply. Switch on the main switch. Put on the air handling unit fan. Record the dry bulb and wet bulb temperature at the inlet and at the outlet of the duct by using psychrometer. Switch on the compressor and allow the system to reach steady state. After that, record the energy meter reading in that compressor. Initial and final reading of energy meter is to be taken. Record the suction and discharge pressures of compressor. Measure velocity head with the help of manometer. Take minimum 4 number of readings in 10 minutes of interval each. So, by the conduction of experiment, we find the observations which are mentioned here in the observation table. Manometer reading is indicated by letter L in mm. This is energy meter reading. So here we conduct the test for the time of 30 minutes with interval of 10 minutes between each two readings. So here this is a initial reading of the compressor energy meter and this is final reading in kilowatt hour. These are 4 temperature readings of the vapor compression refrigeration system. T1 is after compression, T2 is after condensation, T3 is after expansion and T4 is after suction, means after evaporation, means at the entry of compressor. Compressor suction and discharge pressure gauge readings P1 and P2 are given in PSI. At the inlet of duct and outlet of the duct, these are the reading. So this is a dry bulb temperature and wet bulb temperature. So here this is the last column where inlet air temperature of duct as a dry bulb and wet bulb temperature. Similarly here at outlet of duct, these are temperature at outlet, dry bulb temperature and wet bulb temperature. Now by using this reading we can have sample calculation. First we calculate tonnage capacity. Formula for it is mass flow rate into enthalpy difference between inlet and outlet of the air. H1 is enthalpy at inlet of duct and H2 is enthalpy at outlet of duct. 3.517, this is a conversion factor from kilowatt to TR, means ton of refrigeration. Air conditioning in that condition of air which are taken. So air properties are measured by using psychrometer at the inlet and outlet of the duct. So inlet conditions as a dry bulb temperature and wet bulb temperature, and at outlet of the duct, outlet conditions as dry bulb and wet bulb temperatures. We need psychrometric chart to plot the process. So let us understand psychrometric chart. It is a graphical presentation of thermodynamic properties of moist air. Psychrometric chart is drawn for standard atmospheric pressure of 760 mm of Hg or 1.01325 bar. This is a psychrometric chart which contains different lines. In order to understand, let us take one point. We will take sample lines passing through this point, which will represent the properties of moist air. So this is a vertical line passing through this point, which represents dry bulb temperature. So dry bulb temperature values are mentioned at the bottom here on the x-axis here. Line passing through this point, horizontal. Here at the right side, here is a scale of specific humidity where we find the value of W in kg per kg of dry air. On the left side, on the saturation curve where this line will reach, here dew point temperature is obtained. This is a line which gives wet bulb temperature. Extension of this line on the enthalpy scale gives value of H in kilojoule per kg. This is a curved line which represents relative humidity in percentage. This is one more inclined line which gives specific volume in meter cube per kg. In order to calculate specific volume of air at any point on the chart, formula is VSA plus this is a distance. So VSA means this is a nearmost line of the point, its specific volume, and distance between the line and point in mm, and this is a multiplier. So by doing the calculation, we can calculate specific volume of the given point on the chart. Extension of this horizontal line to the vapor pressure scale, we find here value of partial pressure of vapor means PV in mm of Hg. Now we will see the procedure of plotting of psychrometric process on the psychrometric chart. So for that we need here set of temperature at inlet and outlet. So at inlet take dry bulb temperature. So from the dry bulb temperature value on the chart, draw the vertical line, project vertical line in this way. This is a wet bulb temperature, project the WBT line parallel to the WBT lines. Intersection point, this is a point number 1. Similarly follow the process for outlet condition. So this is the dry bulb temperature at outlet, projecting the line. This is a wet bulb temperature, projecting the line. Intersection point, point number 2. Join line 1, 2. So this is a psychrometric process which is here called as cooling and dehumidification, because in this process from 1 to 2 dry bulb temperature is decreasing and specific humidity value is decreasing. So this is a cooling and dehumidification process. When we extend point number 1 line on the enthalpy scale, here we find enthalpy of air at the inlet H1, and similarly from point number 2 extension of this line on the enthalpy scale, we find enthalpy at outlet of the duct in kilojoule per kg. So from psychrometric chart, write the enthalpies of H1 and H2 in kilojoule per kg. Angle of inclined tube manometer. To find this angle, we need here distances. So this is a triangle. So 150 mm is a distance between these two vertical limbs, and these are the bottom points. So 15 mm is a distance between these two points. So let us take tan ratio, means tan theta is equal to 15 divided by 150. So angle theta is equal to 5.71 degree. Manometric head of fluid HF can be calculated by using this diagram. So here is a HF, theta, angle, L is a manometric fluid length from the observation table in mm. Let us take sine ratio. So HF is equal to L sine theta is equal to value of L in mm. Sine of theta is calculated, so find the value of HF in mm. Density of manometric fluid. To find this, use the formula specific gravity multiplied by 1000. Specific gravity of manometric fluid as an alcohol is given. So we find density of manometric fluid in kilogram per meter cube. Density of air we can obtain by using formula rho A is equal to P upon RT for air. So this is a pressure of air, atmospheric air in a bar 0.95. Conversion it into Pascal or Newton per meter square. So multiply here with 10 raised to 5 divided by, this is a gas constant of air Ra in Joule per kg Kelvin. This is a temperature of air. This is a conversion into Kelvin. So by the calculation we find value of rho A in kg per meter cube, that is air density. Manometric head means in terms of air column. To find this we use concept of fluid mechanics. So here we know that in a fluid mechanics pressure is equal to product of rho into G into H. So we can write rho GH for the air column and fluid column. In this case on the both side cancellation of term G, that is acceleration due to gravity. So remains rho A HA into rho F HF. Arranging this equation in the term of HA, we find rho F HF divided by rho A. Putting the value of rho F, density of manometric fluid, HF value, this value is in mm, we need in meter, so conversion into meter divided by rho A, which is calculated here. So by the calculation we find manometric head in air column in meter. Velocity of air which is passing through the duct can be obtained by using the formula V is equal to square root of 2gh. So this is VA is equal to square root of 2gHA. Value of HA putting here and calculation, we find the value in meter per second, that is velocity of air. Area of duct. Here shape of the duct is rectangular, dimensions are given in mm. So area of duct we convert into meter square. So by the calculation we find area of duct in meter square. Discharge of air passing through the duct is obtained by using formula area into velocity of the air. So area of the duct in meter square and velocity in meter per second. We find discharge in meter cube per second. Mass flow rate of air passing through the duct. So unit of this is kg per second. To find this we can use product of discharge and density of air. So discharge in meter cube per second, this is a value. Rho A is already calculated. By the calculation we find mass flow rate of air in kg per second. Refrigerating effect means cooling effect can be obtained by using formula mass flow rate of air multiplied by enthalpy difference along the duct. H1 is enthalpy of air at the inlet and H2 is enthalpy of air at outlet. So from the psychrometric chart, value of H1 and H2, putting over here value of MA, calculation of refrigerating effect we find here in kilowatt. Tonnage capacity is given in TR, so this kilowatt we convert. So this is a conversion factor. Refrigerating effect in kilowatt divided by 3.517. So we find value of tonnage capacity in TR. Next is actual COP, means coefficient of performance of the system. In this, compressor work is to be measured. So here electrical consumption done by the compressor is measured by using energy meter. So here we take initial and final reading of the energy meter. Formula of compressor work is energy meter final reading minus initial reading divided by time of the test. So here final and initial readings from the observation table divided by time in minute. This we convert into second. Thus we find work of compressor in kilowatt. Actual COP is a ratio of refrigerating effect to compressor work. So refrigerating effect and work, both values in kilowatt, we find actual COP. To find the theoretical COP, pressure at inlet and outlet of compressor is to be taken. So here absolute suction pressure is required. It is a sum of pressure gauge reading and atmospheric pressure. So at the suction P1 pressure is equal to pressure in PSI, conversion factor into bar as a 14.5, atmospheric pressure is 0.95. So P1 we get in a bar. Similarly we calculate absolute discharge pressure as exit of compressor as a P2 in bar. By using pressure values, we can plot the vapor compression cycle. So there is a special video on the process of how to plot vapor compression cycle on the pH chart in practical, that is test on vapor compression test rig. You can watch that video. Here we will discuss in a brief. So here you see suction pressure line, this is discharge pressure line, which are horizontal drawn. As per the temperature reading, after compression point number 1, after condensation point number 2, after expansion point number 3, and after evaporation point number 4. By using this temperature, we locate these 4 points. After that, through these points, we project lines vertically on the enthalpy scale. So here we find from this line enthalpy H1, from this line enthalpy H4, and from this line enthalpy H3. Writing these enthalpies, formula of theoretical COP is ratio of refrigerating effect to the compressor work. Refrigerating effect for this chart plot is difference between H4 and H3. Compressor work is a difference between H1 and H4. So putting the values which are here obtained from the observation table in the formulae. So we find theoretical COP. Finally, we enlist the results in that actual COP, theoretical COP, and tonnage capacity. If we observe here actual COP and theoretical COP, then we find that value of actual COP is less than theoretical COP because of losses which occurs in compressor line, pressure drop occurs in condenser line, and pressure drop occurs in evaporator line. So at the end of this session, you can explain practical relevance, importance, and the procedure of conducting trial on air conditioning test rig. You can also determine theoretical and actual coefficient of performance along with tonnage capacity of air conditioning test rig. If you like this video, please subscribe and share. Thank you.